Ever wonder how Amazon gets your order to your door so fast? The answer? Math. Like a lot of math. I don't work for Amazon, but I am a PhD student in operations research. In OR, we use math to improve decision making. One subfield of operations research is supply chain optimization, of which Amazon is a prime example. Think of all the decisions that affect how fast you get your order, how much inventory to keep, where to store the products, how to distribute the products, and every one of these decisions has a huge wealth of academic research behind it. Let's look at 3 examples. First, demand prediction. To get your order to you as fast as possible, the item needs to be in stock, but storing extra inventory can be costly. This is where predictive modeling comes in. Based on users' past behavior and the time of year and the day of the week and the time of day, these models seek to predict how many orders they'll receive of each product. Another huge decision is where to put all these buildings, the manufacturing plants, the warehouses, the distribution centers. The basic optimization problem here is called the facility location problem. And there are entire fields of study devoted to how to set up each of these buildings. How can robots be used to optimize picking and packing? Where should each product be placed within the warehouse? And then, of course, is the transportation. You've probably seen a giant Amazon 18-wheeler on the highway. These trucks, of course, are not the ones that bring the goods to your house. They're bringing goods in bulk between places like the warehouses and distribution centers. Optimization problems for the middle mile include things like which trucks should the products go on, what routes should the trucks take, who should drive the trucks, and finally, there's what we call the last mile. This is where your Amazon driver brings the package to your doorstep. There are so many decisions to be made here. Your order could be delivered by an Amazon truck or a contractor or even a drone. Last mile delivery includes one of my favorite math problems, the vehicle routing problem. In this problem, we have a fleet of vehicles and we need to decide the route that each of them will take. What did I tell you? It's a lot of math. And of course, there's ethical questions related to supply chain logistics. Are the most cost-effective decisions always best for the consumer or the employee? How should we decide what to optimize? Amazon is controversial, but love them or hate them, you gotta admit, they're a masterclass in logistics.